If you're building retrieval augmented generation or RAG apps in enterprise environment, you are likely sitting on two huge security vulnerabilities. First, privilege escalation. A junior engineer asks the RAG bot about company policy, and the vector store happily pulls up context from an unencrypted executive salary document. Second, PII leakage. Your vector store retrieves raw customer phone numbers, emails, and social security numbers and shoots them straight to a third party LLM API. Congratulations, you just violated GDPR, HIPAA, and your legal team's sanity. Today, we are fixing both. Welcome back to Tiny Tech Talks by Amit. In this video, we are building RAG Shield, a lightweight, zero-trust security middleware written in Java 21 and Spring Boot 3.x. We are going to intercept semantic vector searches, enforce pre-retrieval role-based access control or RBAC directly inside Pinecone, and apply post-retrieval PII redaction using Stanford's CoreNLP and custom Java regex before the prompt ever touches the LLM. All the code is open source and linked in the description below. Drop a star on the repo, grab your favorite coffee, and let's dive into the code. Before we jump into VS Code, let's look at the threat model and the execution sequence. When a request hits RAG Shield, it doesn't just run a naive vector similarity query. It does pre-retrieval RBAC. Spring Security authenticates the request and extracts users' authorities, for instance, role user versus role manager. Second, metadata injection. Before hitting our Pinecone serverless index, RAG Shield dynamically builds a metadata filter expression, which is called security level in role user. Pinecone prunes unauthorized document vectors before returning top K matches. Third, post-retrieval PII redaction. The returned text chunks are passed through our dual engine enterprise redactor. We use Stanford CoreNLP named entity recognition to detect context-bound entities like names alongside descending offset regex engines for structured data like email, phone numbers, and SSNs. Fourth, safe prompting. Only sanitized context is returned to your application or the LLM layer. Let's look at how this is built in Spring Boot. Let's open Pinecone RAG Shield service.java. Notice how cleanly this integrates with Spring AI and Spring Security. We grab the logged in users' granted authorities dynamically. We then construct our Pinecone search filter. When we pass this search request to Pinecone, Pinecone evaluates metadata tags at the vector level. If an executive document has security level as role admin and our user only holds role user, that vector is mathematically invisible to the query algorithm. Privileged escalation eliminated. Now what if an authorized document contains a sensitive PII that shouldn't leave your internal network? Something like a phone number in this Pinecone record. That's where enterprise redacted.java comes in. We combine statistical machine learning and regex matching. Stanford CoreNLP parses the sentence structure to identify human names, which is person entities, without relying on rigid string matching. For structured strings like email, phone numbers, and SSNs, we fall back on compiled Java regex patterns. Pay special attention to line 58. When you redact text, replacing John Doe with person changes the character length of the string. If you replace tokens from left to right, every subsequent character boundary offset becomes corrupt. By sorting detection offsets in descending order and replacing them from right to left, earlier character boundaries stay 100% accurate. Now let's see RAG Shield in action. I'm starting the Spring Boot application using Java 21 virtual threads. I've ingested two records with different security rules using our API search index endpoint. As you can see, I've deliberately put a PII, which is a phone number, for both the records. I've executed two queries, one where the role is manager and the second one where the role is user. As you can see, for the role user document, the document was retrieved, but the username and his email, phone numbers were automatically replaced by person, email, and phone. Your LLM gets the semantic context it needs without ever seeing the sensitive PII. That is how you build production ready zero trust security into your Spring Boot AI pipeline. You can run this RAG Shield out of the box in mock mode for offline local development, or supply a Pinecone API key to connect directly to a live serverless vector index using the multilingual E5 large embedding model in Pinecone itself. The full source code, including complete unit test suites and pom.xml configuration, is available right now at GitHub. If this video helped you think differently about AI guardrails in enterprise Java, drop a like on this video. Subscribe to Tiny Tech Talks by Amit for more production grade Java and Spring AI guardrails. Head over to GitHub and give RAG Shield a star. Until next time, keep your code clean and your RAG pipelines secure. Happy coding!